So this is just a quick video to go through talking through what I had as far as my answer key for day 26. So for number one, to verify this identity, I chose to start with the left hand side. You just as easily could have started with the right hand side. It's actually pretty similar to this. So when I looked at the left hand side, I talked to a few people today, and a number of people thought to maybe try and multiply by the tangent of theta minus 1, the conjugate in that denominator there, to make it squared and everything. You could do that. There are ways to go about doing that. However, when I look at this one, again, I always try to look at the other side first, just to kind of see what we're comparing it to. So I see that the left-hand side is the tangent and the right-hand side is the cotangent, and I'm like, well, really, I can turn the tangent into the cotangent, so let's start with that. So that was actually the first thing that I did. So I changed our tangent into the cotangent. So 1 over the cotangent minus 1, 1 over the cotangent plus 1. Now, I did it using common denominators right here. I had a couple people ask if it was possible to multiply by the cotangent over the cotangent. Absolutely on that one. If you did that instead, you would have gotten, just a little sidebar here, you would have gotten 1 minus the cotangent over really 1 plus the cotangent, and like magic, you already have it. So you absolutely could have done that right away. I chose to show the longer way just because I didn't know if everybody would think of doing that. So I got common denominators, changed 1 into cotangent over cotangent, same thing in the denominator part here. So 1 minus the cotangent over the cotangent and 1 plus the cotangent over the cotangent. Again, because it's a division problem, really that means that we're multiplying by the reciprocal. Our cotangents cancel out and we get our final answer there. Again, it would have actually been pretty similar if you did the right-hand side, if you changed your cotangents into tangents. I had a few people also changing tangent into sine over cosine and working through it with sine and cosine and getting the same thing. Absolutely. Again, there's different ways to go about that. Looking at number 2, I chose to work from the left-hand side here. I can show the right-hand side as well. When I looked at the left-hand side, I saw sine cubed, and I'm like, ugh, sine cubed, I don't know anything with sine cubed, but I know I can rewrite sine cubed as sine squared times sine. So if I did that, again, our ultimate goal is going to be to get a cosine in the denominator. So I'm like, all right, I can replace sine squared with that 1 minus the cosine squared. And again, we don't have any squareds on the right-hand side. So I'm like, okay, well, what if I factor that? So 1 minus cosine and then 1 plus the cosine. And what that does is that enables us to cancel that part out there. So we get 1 over the 1 minus cosine and then the sine in the denominator. Now, we have the 1 minus cosine in denominator that we want. That's good. But our numerator, we want it to be the cosecant. So when I looked at it, I saw we have a sine in the denominator, but the sine is 1 over the cosecant. And again, if you're dividing here, it's the same thing as multiplying by that reciprocal. So that means the cosecant is actually now in our numerator, and we got it. Again, you absolutely could have also worked with the other side. If you have the cosecant here and 1 minus the cosine right here, probably the best way to start with this. Again, we want to get some squareds or cubes even on that side. On this one would be to multiply by that conjugate. So we got that here. So that gives us, I'm not going to multiply this out just yet, but notice it is in parentheses here. In the denominator, I'm going to multiply that out. We get 1 minus cosine squared. Sorry, right there. And so here we want it to be a sine in the denominator, so we know that 1 minus cosine squared is the sine squared. Sorry. Okay. So now we need to kind of look at this here. If I look at that numerator right here, I have a cosecant, so I'm out of room here, but I can change that into 1 over our sine here. And then that's times 1 plus the cosine of theta here. And we're almost there. Again, I'm looking at my ultimate end goal. I have a cosine plus 1. I just have it in the different order in that numerator there. So cosine plus 1. And then again, if I have 1 divided by the sine, if you're dividing by the sine here and then dividing by another sine squared, we get a sine cubed in the denominator. So that's how we can go through and verify that using the right-hand side instead. Okay. All right, let's look at a couple of the reviews here. Number 3, this one, again, all of them are in terms of sign. It equals 0. When I look at this, I see a trinomial. Let's factor it. So 2 sine of x minus 1, sine of x minus 1, set them both equal to 0. We want to know where is the sine 1/2 and where is the sine 1. It's 1/2 at pi over 6 and 5 pi over 6, and the sine is 1 at pi over 2. That's how we get those two answers. Number 4, this one's one that's a little bit more complicated here. Again, there's only a sign in here. When there's only a sign, we know we can really think about, all right, I'm going to need to adjust my interval. So this is my adjusting the interval over here. From 0 to 2 pi, we're going to do 1/2 times the x plus 3/2. So we're going to have to add 3 pi over 2, then multiply by a half to get our new interval. I'm going to divide by 2 right here to get the 1/2. So we know the sign is 1/2 at pi over 6 and 5 pi over 6. Pi over 6 is not in this interval. Okay, so, but 5 pi over 6 is. I could keep trying, like if I added 2 pi to 1 pi over 6, we get 13 pi over 6. That's what, 2 and 1/6. That it does not fit on this one right here. That's bigger than 7 pi over 4, so that's not 1 either. So we really just get the 1 answer here. I got common denominators and then subtracted 3 pi over 2. All right, for number 5. This one looks crazy complicated, but we have to use our identities on here. So when we're looking at it, if I have the cosine of, like we had it as cosine of a plus b, if you look on your identities form there, and that equals the cosine of the first part times the cosine of the second minus the sine of the first times the sine of the second. So all of that is just straight from an identity. And then minus this one. Again, this is a difference identity that we have. That's this one right here. So this one, sine, cosine, cosine, sine with a minus. Again, that's straight from our identity sheet. I think the identity sheet might list it as a plus b or a minus b, but it's the same thing. We're just using x and pi here. So I do have a minus in between. We want to kind of be cognizant of that it's going to distribute there. So then we know that the cosine of pi is -1 and the sine of pi is 0. So really, this term is gone and this term is gone because it has the sine of pi, which is 0. So I just wrote it down here, but again, those terms are gone. And then right here, we have the cosine of x times -1, so the negative cosine of x, and then right here minus the sine of x times -1. Notice it's a negative and a negative, which makes that a positive there. Couple ways that you could do this one from here. I set them equal to each other on this one here. So the sine of x is equal to the cosine of x. Technically speaking, you could have squared both sides. That way is much longer. You actually could have thought, where are the sine and cosine the same? If you think about it, right here and right here, those are the two places where our sine and cosine are both root 2 over 2. You could have solved it that way. I divided both sides by the cosine of x. That's the tangent right here. And the tangent is 1 at pi over 4 and 5 pi over 4. All right, number 6. This is another one where we have to adjust our interval here. Notice in the inside part, I factored out a -2 to give us x plus pi over 3. Notice when we do our interval, when we multiply, first I added pi over 3 to 0 and 2 pi, but then we multiplied by -2. When you multiply by a negative, notice that those inequality symbols flipped on that. That's really important right there because now we have the opposite. So when I rewrote it, I wrote it from smallest to biggest. So this part corresponds to that -14 pi over 3, and then this part corresponds to the -2 pi over 3. I just like to list it from smallest to biggest. All right, so we go through and we need to think Where is our tangent equal to -1? And that's at 3 pi over 4 and 7 pi over 4. Neither of those are in the interval. So we know we need some negatives. I started subtracting 2 pi from each of them. So I subtracted 2 pi. And again, you want to think about which ones are in the interval and keep going until you get ones that are not in the interval. So if you subtract 2 pi from the 7 pi over 4, we get negative pi over 4. That one doesn't fit. But here, if I subtract 2 pi, I get negative pi over 5 pi over 4. That fits. If you subtract 2 pi again, you get two angles that both work. Subtract 2 pi from this one, and we get negative 17 pi over 4. Again, we're finding all the coterminals. This one's even smaller. If I subtract 2 pi, that's too small. So we actually end up getting 4 numbers in our interval that work there. Then divide by -2, subtract pi over 3. It's kind of a long one with common denominators, but we get our answer. All right, last one to look at here. We do need a calculator here. We get the cosine is equal to -2/3. So again, what we're doing here when we're using our calculator on it, if I'm now doing the inverse of that -2/3, that should give us x. Remember, inverse really switches. We say switches the x and the y, switches the domain and range on there, but it switches those parts right there. So we're solving for the angle, we're solving for x. So our calculator only gives us the inverse cosine function. So inverse cosine function is from 0 to pi. So it gave us this value right here, 2.301 would bring us in quadrant 2. This over here, remember, would be pi or 3.14. So we need to find the other one. We know the cosine is negative right here. So again, if this is positive 2.301, this is negative 2.301. Again, all the way around is 2 pi. And so we really want the angle, the positive angle right here. So if I look at this part right here, the remaining part is this 2.301 here. So we're going to do 2 pi minus that 2.301 to get our last answer. Okay, hopefully that helped. Again, always feel free to fast forward, rewind, or whatever you need to see whichever examples you need on here. Okay, bye guys.